Hey everyone, welcome back to my channel Beaker and the Board. Today I am here with an entirely new topic of organic chemistry. My main target is to teach you the nomenclatures, but before that you need to know some representations. There are three ways by which you can represent an organic compound, two of which you have already read till your class 10. Now, how to write the dash formula? What is the meaning of dash formula or structural formula? Suppose if you want to represent a compound, say let's take this. Suppose you want to represent C4H10. Suppose you want to represent C4H10. You want to draw the structure of butane. How will you draw that? Dash formula means you are showing all the individual bonds. As the molecular formula suggests, C4H10. My question to you is that I want you to comment down what is the difference between molecular formula and structural formula. What is the utility? What is the advantage of a structural formula? So, suppose I want to represent C4H10. C4H10 is the molecular formula of butane. Suppose if you want to draw the structure through the dash method, how will you do it? It simply means that all the bonds are represented individually. That means all the 4 carbon atoms are shown and all the hydrogen atoms are also represented with the bonds. All the hydrogen atoms are also represented with the bonds, which is, I think you can understand, which is very hectic. Suppose here I have taken only C4H10. Imagine a compound having 20 carbon atoms. Imagine a compound, if I take suppose C20H42. Do you think it will be easy to represent the compound in such a long way? Representing all the bonds is very hectic, time consuming, hectic and difficult. So to reduce the burden, to make the work convenient, to make the work easier for you, new method of representing a compound has come up. So in the dash method or in the structural formula method, you represent all the bonds in the compound. All the individual atoms are shown with the bonds. While in the condensed formula, how do you write the condensed formula? In the condensed formula, you don't need to show the individual bonds, but simply the carbon-carbon bonds are represented. Like for example, in the first carbon, if I denote them as 1, 2, 3 and 4, I can simply write down as CH3. See, in the first carbon, which I have denoted as 1, the first carbon, which is denoted as 1, has 3 carbon atoms. So I have written it as CH3. Then the second carbon atom has 2 hydrogen atoms. So it is CH2. The third carbon as well contains 2 carbon atoms, 2 hydrogen atoms. So it is CH2 again. The fourth carbon has 3 hydrogen atoms. So it is CH3. It is still less hardworking, still less time consuming than the first formula. Dash formula is a very time consuming process. If it is a small molecule, it is okay. But if it is a big molecule, then representing all the bonds and all the atoms is difficult. That is why the dash formula is not used conveniently, is used very less. So the next one is condensed formula. In the condensed formula, you only show the carbon-carbon bonds. Whether it is having a single bond or a double bond or a triple bond, in that way. You don't need to show all the bonds individually. Like see, here I have denoted only the carbon-carbon bonds. The first carbon, second carbon, third carbon and the fourth carbon are interlinked, are linked to each other through the single bond. The individual carbon-hydrogen bonds are not shown. The individual carbon-hydrogen bonds are not shown in the condensed formula. The next formula is far more convenient and is more important because in your higher secondary classes for your competitive exam, most of the questions come with the bond line formula representation. So you need to understand the topic very well. What is that bond line formula? In the bond line formula, you don't represent any atom. You simply represent by a line. You represent the atoms by line. You represent the bonds by a line. For example, see, we are having in this compound, we are having 4 carbon atoms. Remember that in a bond line formula, each intersection point, this is how I make it convenient for my students. Each intersection point of 2 lines, each intersection point of 2 lines represent a carbon atom. Represent a carbon atom. That means the point at which 2 lines are intersecting, that will be the carbon atom. This is one thing. And the other point you need to remember is that every end of a line, represent a carbon atom. Remembering these 2 points will be enough to understand the bond line formula. Now suppose if I want to show you the representation of butane C4H10 through the bond line formula. How will you do it? See, here we are having 4 bonds. You can see very well that here we are having 4 bonds, right? 4 single bonds. That means 3 single bonds are there. Now see, how does it represent? This is how you represent. Now see what happens. This is one end. So this becomes the carbon atom. As I have said, intersection of 2 lines represent carbon atom. Again, intersection of 2 lines represent carbon atom and the end represent carbon atom. Every end of a line represents carbon atom and every intersection point represents a carbon atom. See, that means here we are having 2 intersection points and 2 ends. That means this is one carbon, carbon, carbon and carbon. Here we are having 4 carbon atoms. Now you can say, ma'am, what about the hydrogen atoms? In bond line formula, you don't represent the hydrogen atoms individually. No atoms are represented. You only draw lines to represent the atoms. In bond line formula, no atoms are individually represented. They are only shown by lines. You need to know that carbon is tetravalent. Whether it is single bond, double bond, triple bond, bonded to heteroatom or something, carbon always form 4 bonds. Every carbon should be having 4 bonds. That means if I say if this is carbon atom 1, so that means it is already having 1 bond from this side and 3 other hydrogen atoms. 3 other hydrogen atoms. The next carbon atom represented as 2 is having 2 bonds from both the sides. It is already having the 2 carbon atom is already having 2 bonds from both the sides. The other 2 bonds will be fulfilled by hydrogen. The third carbon atom also is having 2 bonds from both the sides. From both the sides it is having 2 carbon atoms, 2 bonds. Now see, the other 2 bonds will be satisfied because it is tetravalent. Doesn't matter how many carbon atoms it is having. Every carbon atom must be having 4 bonds. Either by a double bond or triple bond or single bond or bonded to heteroatom. It must be having 4 bonds. Now see, the 4th carbon atom is already bonded to 1 carbon atom. The other 3 bonds will be satisfied by 3 hydrogen atoms. So it doesn't matter which compound it is. In bond line formula, you always represent the bonds by line in such a way that intersection point of every lines Whenever two lines intersect, the intersection point will be a carbon atom, and the corners of the line will be a carbon atom. The hydrogen atoms need not to be represented. It has to be kept in your mind. You will understand simply. Suppose if I want to represent, say for example, if I want to represent pentanol, CH3, CH2, CH, pentan 2 all, CH2, CH, OH, CH3. Suppose this is the compound given to us. How will you represent it? Through the bond line formula. You need to know that we are having 5 carbon atoms. That means 5 dots have to be given. And how many bonds are there? See, 1, 2, 3, 4. 4 carbon-carbon bonds. So, 1, this is 1 carbon atom. This is the second carbon atom. The third carbon atom. The fourth carbon atom and the fifth carbon atom. You need not show the other bond because we are having 5 carbon atoms. So see, we are having 5 carbons. 1, 2, 3, 4, 5. 5 carbon atoms. And what is happening? We are having OH functional group. We are having the hydroxy, the OH functional group at the second position. With the second carbon, we are having OH group. So just represent OH in that way. You don't even need to write carbons. You don't need to write carbon atoms individually. You don't have to write. These are the carbon atoms. At the second carbon atom, represent OH. That is enough. If you match, you will understand. No atoms are represented except the heteroatom. The second carbon atom is having, see, here it is, this one is 1, 2, 3, 4, 5. 5 points, 5 carbon atoms, and at the second position we are having the OH or the hydroxy functional group. Suppose if I want to represent this compound say CH3, CH, C2H5, CH double bond CH, CH2, CH2OH. Suppose this is the compound given to you and you are asked to represent the compound in terms of the bond line formula. Simply count the number of carbon atoms first. We are having 1, 2, 3, 4, 5, 6. Now see, write them first. 1, 2, 3. Okay. Now see, at the 2 position we are having C2H5. We can also write C2H5 in this way. C2H5 can also be written as this, CH2CH3. CH2CH3. That means at the second carbon, let me represent the carbon atoms first. We are having 6 carbons. 1, 2, 3, 4, 5, 6. At the sixth carbon, see, we are having OH. See, I am not teaching you the IUPAC right now. You may say that ma'am is giving a wrong number. It's not that. I am not teaching you the IUPAC right now. I am just giving the numbers randomly. So at the sixth carbon atom, we are having the OH functional group. At the fifth carbon, nothing. Fourth and third carbon, we are having a double bond. So give the double bond in that way. The double bond is between 3 and 4. So I have given the double bond here in this way. And at the 2 carbon, we are having CH2CH3. Again, CH2CH3. That is how it becomes. This is how you represent the bond line formula. Just count the number of carbon atoms, it will be satisfied. All the bonds will be represented, but no atoms are represented. I hope it is clear. If not, if you want me to show bond line formula of another compound, comment down so that I can make a separate video for that. Okay, thank you.